All right, cool. So yesterday we were doing linear equations, right? Pretty
Mhm.
straightforward.
Yeah.
Not that difficult, honestly. It's kind of whatever. Let's move on to something else. We'll still focus on lines and stuff. Let's look at this question. It says determine the midpoint of a line segment with these points. Cool. So don't have to be super precise here. I don't know where my ruler thing went. Let me just reopen this. All right, there we go. We're trying to find the midpoint between 2 points. Is this gonna be a line? Is this gonna be a straight line? If I drew this out and if I join them, is that gonna be a linear equation? Let's say we have something like this. A10, 2 is somewhere here. B6, 8, let's say, is somewhere here. If I join this, is this a linear line? Yes, it is, right? There's no way other way around it. 2 points, if you join them, they will always be a straight line. So how do we find the midpoint? Now the midpoint is a point that's going to be right in the dead center. In other words, it's going to be equidistant from both A and B. This distance from here to here will be the exact same distance from here to here, yeah?
Mhm.
Let me draw this a little bit more precisely so you can see what's going on. We can count it, basically. If you do it this way, you can count it, but there's always an easier way. So 2, 4, 6, 8, 10. 10, 2 is right there. So that's 10, 2. That's our point A. And 6, 8, 2, 4, 6, 8 is right there. And that's our point B. Now, if we join this, see, what do you notice? That you can actually turn this into a triangle, right?
Mhm.
This is 2, that's 8. So this is 6 units. This is 6, this is 10, this is 4 units. So what's the slope of this line? The slope of this line that connects A and B. Well, that's going to be rise over run. It's going to be -3/2. Yeah,
Mhm.
it's negative because it's going down. What about the hypotenuse? How do we find the hypotenuse?
Pythagorean theorem.
Right, so it's going to be 36 plus 16. That's going to be square root of 52. Now that's the entire distance from A to B. We're trying to find the midpoint. That means wherever the midpoint is, the distance from midpoint to either A or B will both be root 52 divided by 2. Do you agree with this?
Mhm.
Now let's see where that's going to be. So this is 6 units. Um, let's half this. So 1, 2, 3 right there. So the distance from here to here is 3. The distance from here to here is 3. This is 4 units. Let's half this as well. So right there. The distance from here to here is going to be 2 units, yeah?
Mhm.
Which is half of 4 units. So this point right there will be the midpoint between B and A. That point right there. Because the slope is exactly half at that point. Rise is 3, exactly half. Run is 2, exactly half. So if you can find what this point is, we know that's going to be the midpoint. And that point is 8 and 2, 4, 5. You see that?
Mhm.
This point is 8 and 5. So therefore that's the midpoint. So that's one way you can do this. But that's the dumb way of doing it. There's a super easy way of doing this problem. This is just for you to understand what's actually going on. This point is going to be equidistant from both of them. The easier way to do this would probably be this. I'm just going to write down our answer here. It was 8, 5. So this was our answer using the graphical approach. It's a good tool to help that helps you visualize the problem, but the easier way to do this is by using a formula. And the formula states this: the midpoint between a line segment between 2 points is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. It's the literal average or the middle between the x values and the y values. So if we plug this in, this is again x1, y1 doesn't matter. You can either let this be x1, y1, or you can let this be x1, y1. The order doesn't matter as long as you have 1, 1 and 2, 2. So here it's going to be 10 plus 6 over 2 and 8 plus 2 over 2. So that's 16 over 2, that's 8. That's 10 over 2, that's 5. And there you go, that's the midpoint. So this method is way easier to do, okay? But you should know how to do it both ways. So that's how you find a midpoint between a line segment. What if we work backwards? This is a problem where we have to work backwards in the sense that they've already given us the midpoint, but we don't know what one of the coordinates is. So E, again, you don't have to be precise with this. We're not going to do the graphical method because we have decimals there. I don't want to bother with that. So we have this point E. That's the one end of a line segment. And we have a midpoint at M, which is somewhere here. But this point M is the midpoint between E and some line segment F. So let's say F is somewhere here. We have this point, we have this point. Now the question is, what's the end of this line segment? So how do you do something like this? You just use the formula. Remember, midpoint is going to be x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So here we know what our midpoint is. That's going to be 11 over 8 and 13 over 4, negative 13 over 4. I just turned it into a fraction. Let's say this is our x1, y1, and f has a coordinate of x2, y2, which we don't know. I think I wrote this the other way around. X1 is 11 over 8. X2 is missing. Y1 is negative 13 over 4. Y2 is missing. And our midpoint is 1 over 2 and negative 3 over 2. There we go. That's our equation that we have to solve. Is this making sense? We're just using this formula, but now the x1, the x2, y2 is missing, unlike last question where the other thing was missing, the midpoint. So now how do you solve this equation? Now we have commas. You can treat them as independent equations. You can treat them as their own thing. I'm going to let this be equals to this. That'll give us our first equation. Now this is not a system of equations because we can just solve it like this. That's our first equation. Our second equation is going to be negative 13 over 4 plus y2 divided by 2. That's going to be negative 3 over 2. All right, how do you solve this equation for x2?
You multiply by 2.
Right, you multiply by 2. 1 over 2 times 2 is just a 1, so the 2 disappears completely. Now what? You subtract 11 over 8, yeah? Again, we have a fraction. It's not a big deal at this level. You just take the LCD, which is 8. So 8 minus 11 is -3/8. That's your x2. And in the same vein, we're also going to find our y2. Multiply both sides by 2. The denominators disappear completely. And then subtract, or I guess you add 13/4 on both sides. What's the LCD between these two terms?
4.
4. So this becomes -12 plus 13/4. So the other point is 1/4. And there we go. That point there is -3/8 and 1/4. So that's how you can solve when a coordinate is missing, given the midpoint. It's just this formula. And we're done. I'm going to steal their triangle. All right, so here we have a triangle. They've given us the vertices. So this is -3, -1, 3, 5, 7, -3. The question is asking us, determine an equation for the median from vertex A. Now this is upped in difficulty by a level or two. What is a median? Do you know what a median is? Can you decipher that from the sketch of the triangle?
It's the middle.
Median is a line that connects a vertex with the opposite midpoint. So median is this line right here that connects a vertex. Every triangle has 3 medians. It could have asked us to find this median or this median. But we're focusing on A to M now. So we need to find an equation of this line that connects A with M. So it's going to be in the form of y equals mx plus b. Our final answer will be in this form. This is going to be the equation for the median line from A. How do we find M, the midpoint? Between B and C. Do we have enough information to find that midpoint?
Yes.
Yeah, it's just a simple formula. So M, the midpoint, is going to be x1 plus x2, so 3 plus 7/2. y1 plus y2, so 5 minus 3/2. That is 10/2, that's 5. That's 2/2, that's a 1. So that's our midpoint. We know this coordinate. So we're trying to find the equation of a straight line from A to M. We know both the coordinates. We know A, we know M, so we should be able to find the equation. Let's first find M. Now this is a different M. This is not the midpoint. This is a slope. This is a small letter M. This is a slope that connects A to our midpoint M. How do we find the slope between this point and this point? You just do rise over run, yeah?
Mhm.
-1, so let's go on rise. -1 to 1, what's the rise?
It's 2.
It's 2. -3 to 5, what's the run?
It's 8.
It's 8. Is the slope positive or negative? Look at AM.
It's positive.
It's positive, so we have our slope. That's 1/4. And now we just need to find our y-intercept. We can find our y-intercept by plugging in any point that's on this line. We only have 2 points that we know of that's on this line. So I guess we could say it's 1, 0 as well, but I'm not sure if it's 1 or 1.1. So I'm going to plug, either one of them would work, okay? I'm going to plug in the positive numbers. So I'm plugging it into this. 1 as our y value. Our m is 1/4. Our x value there is 5 plus b, like that. This is to find the y-intercept. because the question's asking us for the straight line equation. You need m and b. So this will be -1/4. And that's our y-intercept. Therefore, the final answer, the median that connects A to M is -1, sorry, not negative. That's slope is positive, +1/4x, but the y-intercept is -1/4. And there we go. That's the line of the median that connects A to M. And you can also find the median from C to the opposite end or from B to the opposite end. Every triangle has 3 medians. Let's look at this one. This one's also complicated. This one you definitely need a sketch to see what's going on. So we need to build a landfill. What was I gonna say? What's the difference? I don't know if you've heard about this. What's the difference between a landfill and a waste facility? Landfill is where you just straight up dump stuff, okay? For the most
Mm-hmm.
part. But a waste facility is a little bit more advanced. It's an engineered landfill in its simplest terms. What they do in a waste facility is at the bottom, okay, it's something like this. This is your landfill in a waste facility, but this is layered with some sort of a plastic material. It's very strong. One of the issues with, what are some issues? Let's just brainstorm. What are some issues with landfills? Let's say you have a landfill here. What are some environmental issues with landfills? I'll tell you a few. One is that it seeps in through the soil. So it's really bad for the soil.
And it can go into groundwater.
Yeah, exactly. It can penetrate this and go into the water table that's down there. So it's bad for the water as well. And on top of this, it also emits methane, among other gases. Methane, ammonia, carbon dioxide, any organic material. Organic means like food and anything you can think of. When it goes through decomposition, it emits methane, and methane is CH4. It looks like this. It's one carbon and it has 4 hydrogens around it. It's a nonpolar molecule. Methane is really bad for the environment because it's a greenhouse gas. You've heard of greenhouse gases?
Mm-hmm.
Methane is one of the worst greenhouse gases because it can absorb um, the radiation from the sun much more than carbon dioxide. Carbon dioxide is also really bad, but methane is worse. Methane is like at least 20 to 40 times worse than carbon dioxide. So in a landfill, your organic material, when it decomposes, it goes through, well, it emits methane gas into the atmosphere. And not to mention the smell is really bad as well. Let's say you have a house or something close to a landfill, then it's going to smell terrible. A waste facility kind of undoes all of these. The material that you have, it'll never go through this layer. One, so it'll never penetrate the soil. It'll never go through get to the water. Smell, they put some sort of chemicals in it, so smell is gonna be extremely reduced. That's not an issue either. And finally, these issues, what they do at waste facilities is that they actually collect them. They have like these little pipes that come out, okay?
Mm-hmm.
Like these. And this actually collects, this sucks in the methane and the other gases, and you can collect this and use it for some other purposes. So that's the difference between a waste facility and a landfill. Obviously, this is going to be more expensive to build and maintain compared to a landfill. But we have a lot of these in Canada. You can go visit them. It still smells pretty bad, but nowhere near as like landfills. And what they do is like they use like bulldozers and then they like compress the waste as much as possible. So it's extremely compressed. That also helps with the smell. And I think at nighttime and stuff, they cover this so water will never get in. If it rains or something, water won't get in either. So that's the difference between a landfill and a waste facility. Anyways, let's look at this question. Back to this question. So we're planning on building a landfill somewhere. It needs to be the same distance from two towns. The first town is A, so 2, 4, 6, 8. A is here at 1 and 8. B is at 5 and 2. So B is right here. So we need the landfill to be somewhere here, right? If it has to be equidistant, that means this distance has to be the exact same thing as this distance. How do we find that point? What is it called? We've already talked about it
The
today.
midpoint.
The midpoint. So how do you find the midpoint between these 2 points? You can just do it in your head. Midpoint is literally the thingamajig. What's the midpoint between 1 and 5?
It's 4.
Yeah, it's 4. So that point is it's 4, it's 3. I don't know if I drew this right. Actually, no, are you right? It's 3, it's 3. 5 plus 1 over 2 is 6 over 2, that's 3. And the other one is 8 plus 2 over 2, that's 10, so that's 5. So that point there is going to be 3 comma 5, yeah? I don't know if it's exactly what it's supposed to be, but that's the answer. Yes, it is 3 comma 5. Now, can the landfill be anywhere else so that it's going to be equidistant to that point? To those two cities, I mean. What if
If it wasn't on that line anymore, then it could.
it was here? It's not the midpoint, but let's say this distance, we could definitely find that point where that distance is equal to this distance. Or it could be somewhere here. Let's say they don't want the smell or whatever. We can find that point where that point is equal to this point. In fact, turns out there's an infinite number of answers to this question, but they're all related. And the answer to this question is this: that landfill can be anywhere across this line. Because if you take any point here, right, any point that's on this line, and if you find the distance, it's going to be equidistant to both the cities. So now the question is, what in the world is the equation for this line? That would be the final answer. Any point on this line is going to be the right answer for this question. So we need to come up with an equation for this line. Turns out that line, okay, remember this. Anytime you see equidistance or whatever, equidistant, you need to think of the word perpendicular. So this line, okay, I haven't drawn it perfectly, but this line is going to be perpendicular to this line. In fact, this is called the perpendicular bisector. It means it meets the other line at 90 degrees, and it also cuts it exactly in half. That's why we found the midpoint first. So to answer this question, the answer is going to be in the form of y equals mx plus b. To find b, we can just plug in 3, 5. But we first need the m value. Now think about it. How are the slopes of these two lines related? They're perpendicular. This black
Don't
line
you
and
like
this.
the negative reciprocal
Yeah, you did the
of
negative
the other
reciprocal.
slope?
So the slope of AB is going to be negative because it's going down. Rise is 6 units, run is 4 units. So it's negative 3 over 2. That's the slope of AB. What's going to be the slope of our perpendicular bisector?
2/3.
2 over 3, the negative reciprocal. So now we have everything to answer this question. Slope is 2 over 3. Now the only point you can plug in as x and y is 3, 5. You can't plug A, you can't plug B because it's not on that black line. You can only plug 3, 5. Okay, so you could plug this, but I just eyeballed this, so I don't know if it actually goes through 0, 3. So I'm gonna plug in 3, 5. So when the y value is 5, the x value is 3. So B is actually 3, so it does go through 3, 0. So therefore, the answer to this question is that landfill can be anywhere on the line y equals 2 over 3x plus 3. And it would be equidistant to those two cities. So equidistant, keep in mind perpendicular. Cool? Most of these are very easy. Not gonna bother with most of it. It's just the formula, plug and chug. It's just a calculator question. Maybe we do this. I'm just gonna eyeball this one. So we have 2, 2, 2, negative 2. So A is here. And then we have negative 4, negative 4. B is somewhere here. And we have C, which is here. So this is our triangle. Part A says find the midpoint. Look at this, it's super easy. Between 0 and 2, the midpoint is 1. Yeah?
Mm-hmm.
Between 4 and negative 2, what's the midpoint? 4 and negative 2.
It's still 1.
It's still 1. Down here, negative 2 over 2, negative 1. Negative 6 over 2, negative 3. Over here, negative 2 and 0. There we go. It's 3 midpoints, super easy to find. Draw the median from vertex A. Okay, so median goes from the vertex to the opposite midpoint. So it cannot go here. It's not gonna curve. The only place it could go is right there. And it says determine the equation. Well, it's not that
How did you
difficult.
get -3 for like the midpoint of BA?
So negative 4 plus negative 2 over 2. Negative 6 over 2. Negative 3. It's y1 plus y2 divided by 2, right?
Mm-hmm.
So negative 4, negative 2, negative 6 over 2 is negative 3. Negative 4 plus 2 over 2 is negative 2 over 2, negative 1 for the x value.
Okay.
So we're trying to find the equation of that median line. We already know A, we know the midpoint, so we know 2 points that we can plug in to find the y-intercept, but we need to find the slope. And again, this is super simple. The slope is gonna be -2/4. Do you agree with that?
Mm-hmm.
And then it's negative because it's falling. So y is equals to -1/2x plus b. To find the b value, I'm going to plug in this because I like my 0. So 0 is going to be -1/2 times -2 plus b. This is a 1, so b is -1. Therefore, the median is -1/2x minus 1. And you're done. So again, not that difficult. Goes from the vertex to the midpoint. From there, it's just whatever. So we have a circle. And what we know about it is that it has the radius of a circle has end points. -1, 3, so -1 and 3, right there. And 2, 2, 2 and 2. So this is the radius of the circle. Now it says determine the endpoints of the diameter of this circle. Cool. Any ideas on how to do this? We're given a radius, points for the radius. We need to come up with the diameter. I'll give you a hint. You can either, I think this is gonna be the assumption. You can either treat this as the center of the circle, okay?
Mhm.
This point O, that means your endpoint will be somewhere here. Or you can treat this as the midpoint and the endpoint will be somewhere here. So you can get two different answers for the diameter of the circle. So let's say it's over here, x1, y1. Is the radius the midpoint of a diameter? Yes, it
Yeah.
is. So it's going to be x1 equals -1 plus 2/2. So that's going to be x1, and y1 will be 3 plus 2/2. No, I messed that one up because it's the midpoint. The midpoint will be x1 plus x2/2. I'm looking at this. Similarly, the midpoint will be y1 plus y2/2. So x1 will be -2 minus 2, x1 will be -4. And this is 6 minus 2, y1 will be 4. Cool? So if we're assuming this is the endpoint, it's going to be -4, 4. Now, if we're assuming this to be the midpoint, what is our equation for the x? Let's say this point here is going to be our x1, y1. And remember, the midpoint, the midpoint is going to be x1 plus x2 divided by 2. The midpoint will be y1 plus y2 divided by 2, like that. So this will be 4 plus 1. This is 5. This is 4 minus 3, it's 1. So that point there will be 5, 1. So there's two answers depending on which end of the radius you use as the center of the circle. Does that make sense? In fact, no, we can't make that assumption. If it went through the origin, we can say like the other endpoint here of the diameter would be this, but this doesn't go through the origin, so this doesn't work. That's the only two diameters that we do know. So here we're trying to make a garden in the shape of a rectangle. We have 3 of the vertices, but we're missing the 4th vertex. Question is, how can we use the idea of midpoints to find the 4th vertex? So let's say this is 1, 6. Let's say this is 7, 6. Let's say this is 1, 10. This is missing. What's that coordinate?
It's just 7, 10.
It's just 7, 10, right? That was pretty easy. What if it wasn't horizontal? What if it was in this shape? So this is AB, CD, EF, GH. Let's say this we don't know. If we knew every other coordinate, how can we find GH? I think that's the question. We can find this midpoint, right? We can find this midpoint. Those are the only 2 midpoints that we can find. You need to use the idea of a slope, yeah?
Mm-hmm.
This line is going to be perpendicular, not perpendicular, sorry, parallel to this line. So let's say the slope of this is 3/8. The slope of this line is 3/8, negative 3/8. Let's say this point is any point, it doesn't matter, 6, 6. What would be this point? You go 3 units down, yeah? And 8 units across. And that's going to be that point. And the slope only works, this method only works if you haven't reduced this. Don't reduce this. So let's say it was actually negative 6/16. Don't reduce it. Because if you reduce it, you'll end up here. So you can use the slope. You can just add the slope. So you need to go 3 units down and 8 units across to get that missing point. So that's how you can get this. Yeah, we've done this problem. It's basically the same problem, just different, whatever. Now we're building a fair. So we have our point A that's at 310, and we have our point B that's at 13.4. The fair is going to be the same distance from these two, what is this, towns. How do we find that? It's going to be the same distance. Equidistance. What comes to mind when you think of equidistance?
Midpoint.
The midpoint, but there could be multiple points that are equidistant. So the perpendicular bisector would be best. Okay.
Mhm.
So how do we find the perpendicular bisector? It's going to be a line that cuts this line in half. That's one of the properties. So perpendicular bisector. Two properties, cuts it in half, which means it's just goes through the median. Goes through the median. And another one is that the slope would be negative reciprocal.
Mhm.
So what's the midpoint between A and B?
8 and 7.
Yeah, 8 and 7. Now, how do we find the equation of this line that goes through 8 and 7?
You find the slope of the other line.
So what's the slope of AB?
It's 6/10.
It's negative 6 over 10. So negative 3 over 5 is the slope. What's the negative reciprocal of this?
5/3.
5 over 3, exactly. So we have y equals 5 over 3x plus b. Now again, the only point that's on this line that you can plug in to find the
It's
y-intercept,
8/7.
8, 7. Yeah, but if you drew this properly, you could probably find this point, which appears to be 0, 2. But let's see. 7 is equals to 5 over 3 times 8 plus b. So b is going to be 7 minus 40 over 3. So that's 21 minus 40 over 3. So that's actually negative 19 over 3. So your equation is 5 over 3x minus 19 over 3. And there we go. Any point on this line, on this red line, will be equidistant to the two towns. It's not going to be the shortest distance. The shortest distance is going to be this. But any point is going to be equidistant. So now this one says find the coordinates of the point of intersection between the medians themselves. D is going to be 8, 7, and F is 8, 1. So we have something like this. Now the goal is to find the midpoint, sorry, the point of intersection between the three medians. So we're looking for this point in the dead center. Any ideas on how to find that midpoint? It's not a midpoint. Well, it's basically the midpoint of the entire triangle. Slightly tricky. This point is called the centroid. Centroid is where the three medians meet. So the question is, how do you find that centroid point? Well, there's no easy way to do it. You find the three equations and you let them be equals to each other. So let's find the equations for the three medians. So the median between D and F, I think that's the easiest one. What's the median between D and F? So it's 8 plus 8 over 2, that's still 8. 7 plus 1 over 2, that's a 4. Between EF, it's going to be 2 comma 4. Between ED, it's also going to be 2 comma 1. Yeah? So we have the three midpoints. What else do we need to find the median? Well, we need the equation of the lines. So let me find the median from vertex E. So vertex E to this point, we know that median there is 8, 4, yeah?
Mm-hmm.
So we're trying to find the line that connects these 2 points. So the slope is 3 over 12, or 1 over 4. That's our slope. And you can plug any one of these values in to find your to find your intercept. Like this. So B is gonna be 4 minus 2, 2. So that equation is gonna be 1 over 4x plus 2. That's the equation for the median from E. Similarly, we're gonna find the other two. It's just super tedious, but it's not impossible. Let's find the median from D. So our 2 points are 8, 7, and the midpoint between E and F is 2, 4. What's the slope? Well, it's 3 over 6. Yeah,
Mm-hmm.
3 over 6. D to this is 3 over 6. Or that's 1 over 2. Slope is 1 over 2. I'm going to plug in this value to find my B. So it's going to be 4 minus 1. It's going to be 3. So our equation is y equals 1 over 2x plus 3. And then the last one, median from F, our point is 8, 1, and the midpoint between E and D is 2, 1. Wait, what? It should be E and D. It should be 2, 4. Let me just double check. Negative 4 plus 8 divided by 2 is 2. 1 plus 7 divided by 2 is 4. Yeah, it should be 2, 4. So for this one, what's the slope? It is going to be negative. It's negative 3 over 6, so it's negative 1 over 2. And again, I'm going to plug in this point to find my B value. Times 2 plus B, it's going to be 5. So our equation is 1 over 2x plus 5. Is that making sense? So now think about it. We're trying to find the middle point, the middlest point of this triangle, the centroid, where all three medians intersect. Would that point, can we get that point by just subbing in two equations? What do you think? The third one make any difference? No, it would not. To find the centroid, you can just find the intersection between two of the medians. The third one will automatically fit, okay? You can just use 2 instead of using all three because you can't really do 3 equations at a time. So I'm gonna plug this equals this. So we have 1 over 2x is equals to negative 3. X is gonna be negative 6. Plug that in here. Times negative 6 plus 2. I'm just finding the POI by doing y1 equals y2, and then I'm gonna find the y value. So that's negative 3 over 2 plus 2. So that's negative 3 plus 4 over 2. So it's 1 over 2. There we go. That point is negative 6 and 1 over 2. And we're done. Did that make sense?
Mm-hmm.
So that's how you find the centroid in a triangle. It's gonna be the place where two of the medians meet. You don't really have to find the third median. A point is 1/3 of the way from A to B. Determine the coordinates of this point. Explain the strategy that you used. So we have A 1, 7. And then we have B 10, 4. We're trying to find the point that is 1/3 of the way now, not 1/2 of the way, okay?
Mm-hmm.
1/3 of the way. Which means we're trying to find this point. This distance is gonna be 1/3. This distance is gonna be 1/3. This distance is gonna be 1/3. We found the midpoint by dividing by what? 2?
Mm-hmm.
How do you think we find the 1/3 point?
You divide by 3.
Right, let's see if that's gonna work. So if we divide it by 3, we get 11 over 3 and 11 over 3. What about this point? How can we find the other, or 2/3? It's a little bit tricky, yeah? We're gonna have to divide it by something else. It's not gonna be 1/3. It's gonna be 2/3. Let's check. So how do we check this? You can check this by using the distance formula. Anyways, let's come up with this point. It's not as bad as you think. Whatever brought us from here to here, if we add that to this point, we should get this, yeah?
Mm-hmm.
So from 1 to 11 over 3, which is like what? 3 and 2 over 3? How many units across did we go? Just subtract one from the other. We went 2 and 2/3 unit across. From 7 to this. How many units down did we go? You're gonna
4
subtract.
and 2/3.
So it's 21 minus 11 over 3, so that's 10 over 3. So we went this unit down and this unit across, right? So to find this point, you can just add this. And again, we're going down, keep that in mind. And then we need to go this unit across, okay? Plug that in and that'll give you the other point. So slightly tricky, this one. 1/3, you divide by 3 and you can use the slopes to come up with whatever you need it to come up with. All right, cool. Let's call it there for the day.
Okay, thank you.
See ya.